This is SpaceTime, Series 26, Episode 106. Coming up on SpaceTime, the violent accretion disk of a supermassive black hole, studying the nearby monster Centaurus A, and India's lunar rover confirms the existence of sulphur at the moon's south pole. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have for the first time ever captured the turbulent violence of an accretion disk in an actively feeding supermassive black hole. The findings, reported in the astrophysical journal Letters, provide scientists with their first direct observations of this hard-to-see region inside one of the biggest monsters in the universe. Supermassive black holes are the most powerful objects in the universe. They're intense gravity wells, regions of infinite density in zero volume, where the gravitational pull is so strong that nothing, not even light, can escape. Clouds of gas, planets, and even stars venturing too close to a black hole will be torn apart by the monster's intense gravity. They remain swirling around the black hole in an accretion disk like water swirling around the drain in a sink. Material in the accretion disk is constantly being crushed, stretched, and ripped apart, in the process releasing vast amounts of energy at billions of degrees. The subatomic debris then passes beyond a point of no return called the event horizon. Once inside the event horizon, escape velocity becomes greater than the speed of light, and since nothing can travel faster than the speed of light, nothing, not even light, can escape a black hole, hence the name. Here, matter is spaghettified as it falls forever towards the singularity, a place where the laws of physics as science understands them breaks down. But not all the material in the accretion disk is doomed to disappear into the black hole. Some of the superheated material is deflected along powerful magnetic field lines away from the event horizon and out towards the black hole's spin axis, which accelerates perpendicular out from the accretion disk into space. Here, the material is accelerated to relativistic speeds and focused into intense superluminal jets called quasars. These are the brightest objects in the known universe. They shine out like beacons in the darkness and can be visible over 13 billion light-years away. Studying these accretion disks can therefore enhance science's understanding not just of black holes, but of the evolution of their host galaxies and maybe the universe itself. Problem is, most accretion disks are actually quite difficult to study directly. That's because they're actually a long way away and really small. But scientists using the Gemini North Telescope have now made the first detection of two near-infrared emission lines coming from the accretion disk of a galaxy 3ZW002, in the process placing new limits on the size of these magnificent structures. Emission lines are caused when an atom in an excited state drops to a lower energy level, releasing light in the process. Now, since every atom has a unique set of energy levels, the emitted light has a discrete wavelength and acts like a fingerprint identifying its origin. Emission lines commonly appear in spectra as thin, sharp spikes. But in the unique environment of the swirling vortex of an accretion disk, where the excited gas is under the supermassive black hole's gravitational influence and where it's moving at speeds of thousands of kilometers per second, those emission lines are broken into shallower peaks. The part of the accretion disk where these lines originate is called the broadline region. And evidence of an accretion disk can be found in a specific pattern of broad emission lines called a double peak profile. Now, because the accretion disk is rotating, the gas on one side of the disk is moving away from the observer, while the gas on the other side is moving towards the observer. And these relative motions act the same way as the Doppler effect you hear when a siren goes past, changing pitch. The light waves moving away from the observer tend to be stretched. It's called redshifting, while those travelling towards the observer are compressed or blue shifted. So the result from all this is a broadened line with two distinct peaks, one originating from each side of the rapidly spinning accretion disk. Now, these double peak profiles are a rare phenomenon. That's because their occurrence is limited to sources that can be observed nearly face on. But in the few sources where it has been observed, the double peak tends to be found in the H-alpha and H-beta lines, two emission lines for hydrogen atoms that appear in the visible wavelength range. Originating from the inner area of the broadline region near the supermassive black hole, these lines normally don't provide any evidence about how big the accretion disk is. But recent observations in the near-infrared have revealed an area of the outer broadline region that has never been seen before. A team of astronomers from Brazil's National Laboratory of Astrophysics have for the first time detected two near-infrared double-peak profiles in the broadline region of the black hole in galaxy 3ZW002. The hydrogen line originates in the inner area of the broadline region, and a neutral oxygen line originates in the outskirts of the region, an area that's never been observed before. These are the first double-peak profiles to be found in the near-infrared, and they emerged quite unexpectedly during routine observations using the Gemini's near-infrared spectrograph. Back in 2003, observations of 3ZW002 first revealed evidence of an accretion disk, and then a 2012 study found similar results, and this meant there was a black hole that had been actively feeding. So in 2021, the Brazilian team set out to supplement these findings with fresh observations in the near-infrared using Gemini, which has the advantage of being able to observe the entire infrared spectrum in one go. And that's actually quite a big advantage. You see, other telescopes require the user to switch between multiple filters in order to cover the same range. That's time-consuming, and also it introduces uncertainties such as changes in atmospheric conditions and the problems of calibration changes between observations. But because Gemini North is capable of making simultaneous observations across multiple bands of light, the team were able to capture a single, clean, consistently calibrated spectra in which multiple double-peak profiles were revealed. The observations not only confirmed the theorized presence of an accretion disk, but also advanced science's understanding of this broadline region. It also provides clear evidence of the feeding process and the inner structure of an active galactic nuclei. By comparing these observations with existing disk models, the authors have been able to extract parameters that provide a clearer picture of 3ZW002's supermassive black hole, as well as the broadline region of its surrounding accretion disk. The observations suggest that the hydrogen alpha line exists at a radius of 16.77 light days as measured from the supermassive black hole, and the neutral oxygen line originates at a radius of 18.86 light days. By comparison, the distant world of Pluto is just 5.5 light hours from Earth. In other words, the accretion disk around this black hole is larger than our solar system. In fact, the outer radius of the broadline region is estimated to be 52.43 light days. The model also indicates that 3ZW002's broadline region has an inclination of about 18 degrees with respect to the Earth. And the supermassive black hole at its center, well, it's somewhere between 400 million and 900 million times the mass of our Sun. A true monster. This is SpaceTime. Still to come, studying the monster galaxy and black hole Centaurus A, and India's lunar rover confirms the presence of sulphur on the lunar South Pole. All that and more still to come on SpaceTime. Well, while we're on the subject of black holes, astronomers have combined two major Australian radio telescopes and several optical telescopes to study complex mechanisms that are fueling jets of material blasting out of a supermassive black hole some 55 million times more massive than the Sun. The research focused on a nearby radio galaxy known as Centaurus A, which at somewhere between 11 and 13 million light-years away is the nearest radio galaxy to the Earth. Radio galaxies are those with active galactic nuclei, or AGNs, meaning their central supermassive black holes are busy consuming material, releasing vast amounts of energy in the process. A report in the monthly notices the Royal Astronomical Society shows that as well as detecting the plasma that's fueling the large plumes of material the galaxy is famous for, the authors also found evidence of a galactic wind or high-speed stream of particles moving away from the galaxy's core, taking energy and material with it as it impacts the surrounding galactic environment. These new observations of Centaurus A will allow astronomers to apply the knowledge to hypotheses and simulations of how galaxies evolve. One of the study's authors, Ben McKinley from the Curtin University node of the International Centre for Radio Astronomy Research, says the galaxy's proximity, just down the road in astronomical terms, makes Centaurus A a perfect cosmic laboratory for studying the physical processes responsible for moving material and energy away from the galactic core. Centaurus A has been a popular target for astronomers in the Southern Hemisphere for decades due to its size, its elegant dust lanes, and its prominent plumes of material. But McKinley says that being so close to Earth and so big actually makes studying this galaxy a bit of a challenge. That's because most of the telescopes capable of resolving the details needed for this type of work have fields of view which are smaller than the area of the sky that Centaurus A takes up. So to undertake their observations, McKinley and colleagues used the Murchison Wide Field Array radio telescope in outback Western Australia and the Parkes radio telescope in the central west of New South Wales, both of which have large fields of view, thereby allowing them to image a large portion of the sky and see all of Centaurus A at once. Murchison is a low-frequency radio telescope. It has superb sensitivity, allowing the large-scale structure of Centaurus A to be imaged in great detail. And the 64-metre Parkes Observatory, commonly known as the Dish, can complement these observations. Additional observations from several optical telescopes were also used in this work, including the magnificent Magellan Telescope in Chile, as well as several smaller telescopes such as the Tarot Observatory in Canberra and the High View Observatory in Auckland. Also known as NGC 5128, Centaurus A is in the constellation Centaurus. It was discovered back in 1826 by Scottish astronomer James Dunlop from his home in Parramatta. Nowadays, Parramatta is located in the middle of Sydney's sprawling western suburbs. But 200 years ago, it was a mixture of pristine forests and rural pasture lands. There's considerable debate in the literature regarding Centaurus A's fundamental properties, such as its exact distance from our solar system, also whether it's a lenticular galaxy or an elliptical one. One thing scientists are sure about is that it's the most powerful radio source in the region, with an active galactic nuclei that's been extensively studied. The galaxy is also the fifth brightest in the night sky, making it ideal not just for professional astronomers, but also amateur astronomers as well. It's best visible from the southern hemisphere or from very low northern latitudes. By comparing radio and optical observations of the galaxy, McKinley and colleagues also found evidence that stars belonging to Centaurus A are extending far further out from the galactic core than previously thought. And that's led to speculation about whether the winds and jets emanating from the galaxy could be physically pushing those stars away.
Centaurus A is just so close by, and so with our radio telescopes and the optical telescopes as well, we're able to see it in more detail than any other radio galaxy in the universe. And so by learning about Centaurus A, we can then assume that similar things are happening in radio galaxies further away, and we can put that into our cosmological simulations and try and work out basically how the universe has evolved in time since the Big Bang. We've used 2 radio telescopes in Australia and 3 optical telescopes to study the closest radio galaxy, Centaurus A, in new detail. We're looking for relationships between the optical and the radio emission and what's happening with the interaction between the supermassive black hole and the environment around the galaxy. Centaurus A is unique in that it's the closest radio galaxy by far, so we can use very long baseline interferometry to study those jets in the best detail of any other supermassive black hole, well, outside of our own galaxy. So we know quite a lot about the jets themselves. It actually gets harder when you look further out from the jets. The jets create these radio lobes that are actually quite large on the sky, and that makes it more difficult for some radio telescopes that have much small fields of view. So the Murchison Wide Field Array that we've used, and Parkes as well, you're actually able to map the whole radio source and really learn what's happening in those radio lobes that are created by the jet.
How are the jets created?
So there's a supermassive black hole in the middle of the galaxy, and matter spirals into that supermassive black hole and forms what's called an accretion disk, and things become super hot and super fast. They enter that disk, and so basically as the supermassive black hole eats matter, some of that matter is shot out in jets that go either side, sort of perpendicular to the galaxy. And it's because this matter, mostly electrons traveling close to the speed of light, when you get electrons traveling that fast, they create radio waves. And so that's why we see these bright jets when we look at the galaxy with a radio telescope.
And these powerful jets are formed and they shoot out. These are the same sort of things that when we see them across the universe, we call them quasars. Is that right?
Yeah, that's right.
And they've got other names too, blazars and AGNs. And I take it that's all the same thing, just depends on how we see it and where it is?
It's basically the same thing. I think quasars are normally classified as the ones that are sort of from the early universe really far away, and so they're really compact and really, really bright. And the name comes from quasi-stellar objects, so they sort of look like stars because they're just single points, whereas radio galaxies is sort of the same thing, but it's generally the things that are closer and you can start to resolve them and see more of the structure. I think blazars is to do with the orientation angle of the radio galaxy. So there's this sort of grand unified theory of active galactic nuclei where, people think it's all basically the same thing, but depending on the different orientations of the radio galaxy depends on whether you're classified as a blazar or a radio galaxy or a quasar.
And what you guys have been doing is looking at what happens when this jet shoots out from the black hole and interacts with the surrounding interstellar medium, I guess. Yeah,
that's right. So as the jet propagates outward, it hits gas that's going around the galaxy. So other studies have found these big H1 clouds of hydrogen that are going around the surrounding the galaxy. And as they interact with that, they can create more radio emission and X-ray emission. The jets can trigger star formation as well, and they can ionize the surrounding gas. So you end up UV radiation from the AGN causes electrons to be knocked off the hydrogen, and we can detect this with optical telescopes by looking for different radio emission lines.
People are often very surprised when they hear that black holes, which are these things like giant vacuum cleaners, some people envisage them as being, that are just sucking up the universe around them. But as well as that, they do generate these powerful jets as they're feeding, and these jets can push material away from the line of fire, I guess you'd call it, and in the process, that can lead to increased star formation as well.
Yeah, that's right. So we see these bright optical filaments that we describe in the paper, and we show an image of it. And the bright new stars in those filaments are thought to be caused by interactions from the AGN with the surrounding gas.
And they're a lot further out than originally thought too.
The stars, this deep optical image that we have shows this shell surrounding the galaxy, but we've seen additional sort of cloud of stars that seems to propagate out sort of in line with the radio jets, but not quite, out to quite a far distance. And it's not exactly clear the mechanism that's causing that, but due to the alignment with the radio galaxy jets and lobes, we sort of speculate that it has something to do with that, with propagation because of the AGN.
Murchison's proven to be quite a valuable astronomical tool, isn't it?
The Murchison Wide Field Array, it's really good because of the wide field of view. So we lack the spatial resolution of a lot of other telescopes, but we can see across a really wide field of view. So the Centaurus A, if you look up at the sky and imagine 14 full moons across, that's how big Centaurus A would be if you could see it with your eyes. And most telescopes just can see a tiny, tiny fraction of that at any one time. So with the MWA, we're able to see the whole galaxy and image it across a wide range of wavelengths as well.
And that's especially important with something like Centaurus A because it is so close.
Yeah, that's right. So part of our paper was also comparing our observations with some older observations. One set of observations was done with the Australia Telescope Compact Array, which is another interferometer which has a narrower field of view but is able to look into sort of more spatial detail, and then also the Very Large Array in the US. And so there was new observations from the Very Large Array that disputed the fact that there's this large-scale jet connecting the inner radio lobes of Centaurus A with the outer radio lobes. And our observations show that the Very Large Array observations from the Northern Hemisphere are probably not correct because of difficulties they have observing the source because it's so low in the sky in the north. So we've shown there is a large-scale jet that's connecting the inner lobes to the outer lobes.
Do we know what these jets are composed of? You mentioned electrons earlier.
Yeah, sure. So we think, they're mostly electrons because electrons are small enough that they can be accelerated to close to the speed of light and cause this radio emission that we see. It's much harder to accelerate protons up that fast because they're so much heavier.
That's astronomer Professor Ben McKinley from the Curtin University node of the International Centre for Radio Astronomy Research. And this is SpaceTime. Still to come, India's lunar rover confirms the presence of sulphur at the moon's south pole. And later in the science report, discovery of a cancer drug that could target HIV silent cells. All that and more still to come on SpaceTime. India's Pragyan or Wisdom lunar rover has confirmed the presence of sulphur at the moon's south pole. It's the first major discovery by the tiny six-wheeled rover since the Chandrayaan-3's Vikram or valid ascent vehicle became the first spacecraft to touch down near the lunar south pole. ISRO, the Indian Space Research Organisation, says the detection of sulphur was made by the 26-kilogram rover's laser-induced breakdown spectroscopy instrument. It says these in-situ measurements confirm the presence of sulphur in the region unambiguously, something not feasible using instruments on orbiters. The spectroscopic analysis also confirmed the presence of aluminum, calcium, iron, chromium and titanium, together with manganese, silicon and oxygen, and it's still continuing its search for signs of frozen water. The solar-powered rover will spend half a lunar day, the equivalent of 14 Earth days, exploring the terrain around this relatively unmapped landing site, transmitting images and scientific data back to mission managers. On Monday, the rover's exploration route had to be changed after venturing too close to a 4-metre-wide crater. The rover's journey of exploration on the moon isn't fast, travelling at just 10 centimetres per second so as to minimise shock and damage from the moon's rugged terrain. The Chandrayaan-3 or Mooncraft 3 in Sanskrit mission has captivated the Indian public's imagination since its launch 6 weeks ago. Its successful touchdown on the lunar surface last week was viewed by thousands of cheering spectators. An achievement made even more poignant by the Russian lander Luna 25 crashing in the same region while attempting its own competing landing. Mind you, it hasn't been all beer and skittles for the Indian Space Agency. A previous landing attempt back in 2019 by the Chandrayaan-2 ended in failure. In fact, only 3 other nations had achieved a soft landing on the moon: the Soviet Union, the United States, also the only country to have sent people there, and China. But India is fast becoming a major player in the space industry. In 2014, India became the first Asian nation to achieve orbit around Mars, and it hopes to undertake its first manned space flight into Earth orbit next year. And ISRO's just launched its first scientific mission to observe the Sun. The Aditya L1 will study the Sun from the Lagrangian L1 position, about 1.5 million kilometres from Earth. Aditya, which means sun in Hindi, will be placed into a halo orbit around L1, which is a sort of gravitational balancing point between the Earth and the Sun. The orbit is shared by a number of other sun-studying spacecraft, including the joint NASA-ESA Solar and Heliospheric Observatory spacecraft SOHO. Aditya's mission is to try and understand the dynamics of the solar wind using its 7 scientific payloads, including an electromagnetic and particle light detector which will observe the Sun's outermost layers, the photosphere and chromosphere. But the tiny spacecraft's first task will be getting from Earth orbit out to L1. We'll keep you informed. This is SpaceTime. time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have found an existing blood cancer drug that's shown promise in killing silent HIV cells. The discovery by researchers at the Peter Doherty Institute has already been shown to help delay the virus from re-emerging in patients being treated with antiretroviral cocktails. Hidden HIV cells, known as latent infection, are responsible for the virus permanently remaining in the body and cannot be treated by current therapies. The new findings, published in the journal Cell Reports Medicine, are based on research in which scientists looked at blood cells from patients infected with HIV and the impact of the cancer drug venetoclax, both alone and in combination with another drug known as S26E106. They found that venetoclax killed HIV-1 latently infected cells, and that the drugs were able to delay the time it took for the virus to bounce back once antiretroviral therapy had stopped. A clinical trial based on the findings will now be launched in Denmark and Australia to test whether venetoclax can be used as a potential pathway to develop a cure for HIV. There are an estimated 40 million people worldwide currently living with HIV, the virus that causes AIDS. Included in that count are more than 29,400 Australians. Scientists have developed a new test which could help predict who's likely to get dementia in the next 14 years. A report in the British Medical Journal claims the test, known as the UK Biobank Dementia Risk Score, was developed using data from over 200,000 people. It works by looking at 11 predictive factors. These include age, education, a history of diabetes, a history of current depression, a history of stroke, parental dementia, economic disadvantage, high blood pressure, high cholesterol, living alone, and being male. The researchers also looked at whether people had the gene ApoE, which is a known risk factor for dementia. When they used the test on a separate group of 70,000 people aged between 50 and 73, the test performed better at predicting who would develop dementia over 14 years than 3 other current dementia tests. Well, the biggest search in more than half a century has been underway in the Scottish Highlands looking for the elusive Loch Ness Monster. Hundreds of amateur researchers and enthusiastic Nessie hunters from around the world have been braving the pelting rains in order to scour the 36-kilometre-long, 240-metre-deep loch using everything from drones and thermal imaging cameras to sophisticated sonars and underwater hydrophones, with the aim of unravelling a mystery that's captivated the world's attention for generations. Reports of an aquatic monster lurking in the loch's murky depths go back to ancient times. There are even rock carvings in the area depicting a mysterious beastie with flippers. The earliest written record of the creature can be found in the biography of the Irish monk St. Columba in the year 565. Since then, there have been thousands of alleged sightings, most commonly describing a prehistoric marine reptile from the age of the dinosaurs known as a plesiosaur. Of course, chances of actually finding the mythical beast range from slim to non-existent. Hundreds of blurry images and a couple of not bad fakes have turned up. But if there really is something there, then it's more likely to be a giant sturgeon, a humongous catfish, or possibly a new species of giant eel. Other possibilities include a lost seal or shark that swam along the canal connecting the loch to the North Sea. However, to be honest, the end of the legend really happened back in 2018. That's when scientists from Otago University in New Zealand undertook a detailed environmental DNA search of the loch, and they found no unexplained DNA sequences in the lake's dark waters. Absolutely nothing that could be attributed to Nessie. Well, they may just have reached the surface of the moon and are planning to launch their first manned mission into orbit next year, but India's time as a modern, scientifically advanced spacefaring nation may wind up being rather short-lived. You see, Indian authorities are dumbing down the country's education system. They're cutting key scientific topics from the curriculum, including the periodic table and evolution. Tim Mendham from Australian Skeptics says the move is being pushed along by a strong nationalist movement within the government.
In India, there's a bit of a drive on to promote what they call Hindu science, locally developed science that supposedly goes back thousands of years to show that we don't need all this Western stuff. We had it all before in India. There's a suggestion, what's happened now is that, especially for 15 to 16-year-old students in high school, in secondary schools in India, in their science classes, all references to evolution, the periodic table, climate-related topics have been cut from textbooks. So kids who are studying biology at that level, which is the general level of people doing science, are not being taught evolution, which has been criticised by saying not teaching evolution in biology is like not using numbers in mathematics. It's the basis of it, it's the core of it, it's highly important. So by having it cut out implies there's a certain bias in what things are being presented. It's not just downplayed, it's actually cut out of the textbooks. It's like a pair of scissors been taken and sort of taken all these subjects out. The authorities claim that the content is covered elsewhere and that it's difficult to explain, and they say it might be irrelevant anyway. Well, it's not irrelevant, obviously. Evolution is not irrelevant to biology in the same way as the periodic table is not irrelevant to chemistry. And it's difficult? Well, that's up to the teachers, isn't it? The way you teach. You can teach evolution. Pretty straightforward. You don't have to become a PhD at high school level. And the content is covered elsewhere. Well, that's hard to say because basically it means that kids who go up to age 15, 16 and who don't choose to go into science classes are not being taught this stuff. Hopefully it's taught later on for the time being anyway, but that's only for people who choose to do science. So the general public is not going to hear about evolution, periodic tables, climate change, energy sources, all sorts of things like that, there is a general anti-science, pseudo-science move that's going on in India, whether it's in education, even at university level. There's some very strange theories put forward, such as that the Indian god with an elephant head on a man is evidence of advanced surgery by Indians thousands of years ago, that all sorts of strange things that have been put forward in Indian circles, often by people who should know a lot better. There's a move on to try and stop this, but it's having a hard time. So it is supported at the highest levels of politics.
Is this just one political party or is this across the board?
It's mainly Modi's party. Well, the claims are actually being put forward as a general movement, and it's definitely being supported by Prime Minister Modi for the last close to 10 years, and it's hurting India's development.
What does that do for India? It's now the world's largest country in terms of population. What's that going to do for the development of the nation?
It's also a country that is pushing itself as an advanced nation. It's got a huge university education resource. It's got a lot of research they're trying to sort of push through. But this obviously, one, it makes them look a bit silly, and two, it'll be raising people who really don't have a broad enough understanding of what's going on.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.